Have you seen this equation from your what do you call it? From your manual that I have already shared with you? Have you seen this equation? If you have seen it, can anybody tell me what type of equation is this? Is it a oxidation reduction reaction? Is it an oxidation reduction reaction? Can anybody volunteer? Otherwise, I will name call. Yeah, it doesn't matter. You yes or no. Yeah, only yes and no. The answer. If the answer is not correct from you, there is no marks deducted. So no problem. Don't be scared. Belas? Oh, good. So Chelsea said yes. Now my second question is why it is oxidation reduction reaction. Brenda?
Because there are change in the oxidation number.
Specifically, can you say which one is changing?
Or the sulfate.
Okay, good. So Danesh, the sulfate is oxidized or reduced? See, from here, sulfur becomes solid. So it becomes reduced for this case, okay? If we do the oxidation and reduction, oxidation state, find the oxidation state, you'll see the sulfur is reduced here as well here. So this is the oxidation reduction reaction. And then we are going to see more about what is the influence of adding different concentration and different time. Okay, different time and different concentration. Sorry, different temperature and concentration. But for all those, we will keep the total volume same. Only we will change the concentration of these two to make the total volume of the solution the same number, some amount, same volume. So total volume will be kept the same. The temperature will be decreased or increased. Okay, so let's start doing it. It will not take a long time, and it is actually a simple experiment to do. But most of it, mostly experiment, you have to, how do I say? The experiment report actually, it depends on how good you can discuss. All right, because it is quite simple thing. And also you need to prepare the graph. The graph here, it is on page 5. So you have to prepare the graph. The rate of the reaction is just 1 over time. How long it is taking, 1 over time, it is the rate of the reaction. Okay, so let's start doing it. And I'm leaving my phone here. Please let me know if you cannot see. Okay. I hope that you can see. First thing is I have to wear gloves. Safety is the most important thing in the chemical lab. So those who are coming for next week is our mid-sem break and also assessment week actually. So the midterm test will be next 23rd, and after that the following week we will start experiment 6. From after the semester break we'll start experiment 6. Physical lab, that means face to face. Students are coming to the lab to do the experiment. And so far, I have heard from some of you. So if you want to come join the lab physically, please let me know your name. Okay? Email me, please, by tomorrow. We have to confirm because just now our lab assistant was asking me how many students, what is their name. So she has to prepare everything for student because we have to have separate students standing. We cannot, all students are not grouping up. So she has to prepare. Okay, so first of all, I need six beakers, and I'm taking the 6 beakers here. 2, 3, 4, 5, and number 6. So I'm going to label them as A, B, C, D as mentioned in the procedure. So A, B, C, D, and F. Okay. So when students are coming to the lab doing experiments, it's so good. They are cooking for themselves. I don't have to cook for you guys anymore. Oh, another thing, those who are coming to lab, you must, the first thing you do is you have to submit the safety acknowledgement form on Canvas. I will open that safety acknowledgement form submission once again. I will, after the class, I will go and open it. So if you do not submit it, or another way, if you do not acknowledge the safety, then you are not, you cannot come to the lab. Yeah. So that is very important. You have to acknowledge the safety acknowledgement form. You have to submit. So what do I do now? Can anybody guide me? What should I do now? Nobody. First of all, I need to rinse those the beakers and glassware. Okay, so I go and bring some water. So I rinse in this way. I take water and then I just rinse. That means I'm going to use the same water for all the beakers. That is how I can reduce the wastage of water. And I do it twice. All right, so I just leave it for some time, the water to dry out. Let me go and bring some tissue, yeah. Okay, so this is not the perfect way. I should put it in the dry rack, but since the dry rack is not nearby and I'm doing alone, so I just put it on the tissue upside down, inverted way, so that the water, excess water, will be rinsed out, dried out. Okay, now I'm going to rinse this burette. Okay, I hope that you can see. Okay, I rinsed it, so I will leave it on the burette stand for some time, opening the valve. I keep the valve open so the water will be drained out, the excess water. So I have to take the, I need to clean these things as well. Please. Okay. Okay. It will take some time, but does anybody has any question about anything? So that by the time you're waiting, we can actually discuss. You guys are there, right? Okay, so I don't know if you could see it. So I just keep the beakers that I just rinse upright and then inverted way so that the water will be drained and it will be a bit dry. I kept the burette like here upside down and I opened this valve, right? So that if I mean, sometimes students, what they do is just they keep it up, upside down this way, but they close the valve. They do not open the valve. So if they close the valve, what will happen is the water is here. It will not come out. And also, if something is stuck inside, it will not drain out. You have to have some air pass through it, right? If the water has to come out, it has to fill with air. So if you after you clean it and wash your burette, please keep it upside down like this and keep open the valve. Okay, so this is the trick, and I think it's almost dry, so we can start. All right, so let me go and bring the sodium thiosulfate solution and fill up the burette. If you cannot see it, please let me know. I cannot see the chat box or anything. You have to talk. So how do I take sodium thiosulfate? I will use a little bit, maybe 2 milliliter to rinse, or 1 milliliter to rinse the burette. Okay, I hope that you can see. Okay, I've taken the sodium sulfate solution here. Okay. So in A, for A beaker, I will take, according to the table 4.1, is 10 milliliter A until D. I will take 10 milliliter everywhere. So I'm just taking 10 milliliter of sodium sulfate solution. I'm just starting from 0, so should be taking 10 and then I'll stop. Okay, so for A is 10 milliliter, In B, it should be 10 milliliter as well. From 10, 20 should be yep. 10 for C, it is 20 milliliter. Oh, sorry, 10 milliliter as well. So 20 to 30, it should be. For D, it is 10 milliliter as well. So 30 to 40. It's 30 to 40 for D. For E, I will take 25 milliliter. But to take 25 milliliter, I need to top up the burette. So okay, so now for E, I will take 25 milliliter of sodium thiosulfate. I'm starting from 0. I should stop at 25. Exactly 25. And then for F, it says 40 milliliter. But since the burette capacity is 50, I have to top up because there is only 25 left. Little bit. Correct. Yeah. Now I have 6.3, 6.2. So 40 means 46.2 I have to take. And here 46, 40 milliliter I have to take. When you're taking in the burette or especially in the burette, make sure that the initial reading If you forget the initial reading for once, it is total gone. You cannot get back, or you cannot know if you did not take it carefully. All right. 46 point, 40 milliliter I have taken. So altogether, now my burette thing is done already. I'm done. Leave it. I will move the burette from here. And what I'm going to do is I have to draw a X cross mark to know how long it will take to disappear. Why does it get disappear? Can anybody tell me why does it get disappear? Why would the cross mark be disappear?
Formation of precipitate.
Yep. Sulfur, since it is written S and then in the subscript, the bracket, that is another S, small s, what does it mean? It's Chelsea, I think. Yeah. Chelsea, do you know what does it mean? There is an S subscript of S, that is sulfur. I mean, look at the reaction. Look at the reaction in the manual. There is sulfur and then in the bracket S, small s. That means that sulfur will be precipitated or sulfur will be solid. If that S in the bracket means solid. We already discussed about it. What is S, what is L, what is AQ, AQS, or what is gas, G. So we should always remember those things. It will be important to know, and it will be important for our exam as well. So yeah, since sulfur is solid, that means it will be precipitated here. And because of this precipitation of solid sulfur, we will not be able to see the cross mark, or cross mark will be disappeared, or it will not be visible anymore. Okay, so what I'm going to do is I don't need to draw actually. I have already something here. Okay, let me draw actually X cross mark. Here you can see the cross mark I draw, and I will always use the same cross mark for all the experiment. So there is less biasness. All right. I will, because if I use different type of cross mark, like I draw it here one, I draw another one here like this, another one very deep like this. So it will be different. So I don't want to do all. I just want to use one single cross mark so that it will be a standard reference for all. Right. So I will use this cross mark to see how long it takes to disappear. All right. Now, as per this experiment, the table saying I have to add 35 milliliter of water, deionized water, into beaker A until beaker D, and then what? And then I will use 5 milliliter of concentrated sulfuric acid. All right, 5 milliliter concentrated hydrochloric acid, HCl. Where is it? Yeah, here. You can see, right? So here, hydrochloric acid. And then I'll start the timer. To, just let me be sure of how. Is it better this position or it was better previous position? Hello? Just see, nobody is talking. So can you tell me that this position is okay, or previously that position was better?
This position.
Sorry?
This one is better.
Okay, good. So now A. I have solution, beaker A, and I am going to add 35 milliliter of water by I have this measuring cylinder. So usually this 35 milliliter of water, what I'm doing is just dissolving, diluting the solution, right? This 0.25 molar sodium thiosulfate, and I have taken in beaker A 10 milliliter, and now I am dissolving, I'm diluting it by adding another 35 milliliter of water. So what does it actually do? This water, 35 milliliter of water, it dissolves, it dilute the solution. So the solution becomes, the volume becomes bigger first. Second, the reaction occurs is not that very fast. Otherwise, the reaction will be very fast, and then we don't have enough time to press this. This is the stopwatch. I will not have enough time to press it. I am alone here. So 35 milliliter of water, I will use 10, 30, 35. Now, you should always remember, bear in mind that this measuring cylinder has a tolerance of 0.5 milliliter. That means 0.5 milliliter means, right, half of a milliliter. Whereas that pipette or burette, they have a tolerance of 0.1 or 0.05, something like that. So can anybody tell me which one is more precise? Which one is much more accurate? Bilal?
The pipette.
Sorry?
The pipette.
Yes, the pipette, because it is, it's already written, right? 0.5 and that is 0.05. Okay, so I'm adding 35 milliliter of water. Then 20, 30, 35 of into water. I add to A. I will add 35 milliliter to B and C and D and F. And D, sorry. And then 20 and 5 different. All right, so it's 35 in, okay, not in F, not E. So I have to be careful not to add there, but A and then B. Now I will show you that the level becomes same for all these 4 beakers, because now, from there you will see that we have equal volume of reactant together, right? Okay, so it's C. Okay, I have added same amount of water for all, and then I need to add 20 milliliter for E. So I will use the same volumetric flask to use 20 milliliter. For E, that will be right. Now the measurement cylinder, the work is done with the measuring cylinder. And for F, I will need to add only 5 milliliter of water. So I will be using the small measuring cylinder for that. Okay, so F, I added 5 milliliter of water. Right. Now I am going to show you the level of the 6 beakers. So you can see from here, all the 6 beakers. This is F. Okay, so you can see actually it's A. So you see that all the levels are same levels, all of them. All right. So now I am going to add HCl. All right, one after another one, not all together same. I mean at the same time, but one after another one, and then because I cannot handle all together the same, I have only one timer, and I have only 2 hands, so I'll do one by one. Yeah, I'm going to put the phone there again. All right. So I have to have HCl, 5 milliliter of HCl. All right, I have taken the 5 milliliter of 2 molar HCl, and 2 molar HCl is considered concentrated already. So we have to be careful in handling the HCl. Right. So what I'm going to do is, let me check the timer, how to use this timer. Start, and then stop, and then reset. Okay. So I will put it on the mark. Can you see that I'm putting it on the mark? Of course, you cannot see from there, but you see that I move it from here to on my paper, right? So I'll show you when it becomes how it looks. Let me show you. So this one is beaker A, all right? And I put it on this X cross mark. Now I am going to add this HCl, and then I have to quickly in one hand, right? Let me position it all together so nicely so that I can just press it. All right. So 1, 2, 3. I started the stopwatch, and you will see that slowly, the reaction is started already. But how long does it take? Let me check. Let's wait for some. Still nothing. Still nothing. Oh, it started to change. Can you see that it started to become whitish? Now it's getting disappeared, getting there. I can still see. I think I still see it. I think I still see. Oh, gone. All right. So it is 48.4. Since we have to record the data to 1 decimal place, so I will just put it as 48.4 second. Let me put it in that way. So time the cross disappeared is 48.4 seconds. All right. It's already put, second is already given there, but I don't need to write it here because second is already given here. So I don't need to write it in extra way. All right, so now I'm doing it for B, because doing it for B, okay? You have to wait again. Is it better this way? Can you see the? Is it better this way? Can you see the beaker here?
Yes.
So let me go and bring some ACL for this. Right. So for beaker B, I'm going to use the ACL once again. And it is important that we add all the ACL at a time rather than by pipette. If you pipette, then it is drop by drop, right? 1 drop, 2 drop. No, they're not that way. We want to add all together the ACL. So we want to see exactly when we start. I mean, the first drop when it goes, that means the reaction starts. So we want to start the counting from there. And that's why it is important that we add all the sort ACL at a time. So I'm going to start. Have this. Okay. So 3, 2, 1, go. 10 seconds, but the reaction hasn't started. Or reaction has started, but the precipitation hasn't occurred yet. Still nothing. 20 seconds gone. Still nothing. The 20 seconds, 34, 35, 37, 38, 40, 41, 2, 3. Still can see, disappeared. Okay, so it is 50.2 seconds. All right, it is 50.2 seconds, but I was supposed to do it at 40 degrees centigrade. I have to do it 40 degrees centigrade, but I have done it in the room temperature once again. RT means room temperature, so I will have to repeat this B once again. All right, I will do it, but just consider that this is a repeat for the same A, beaker A. So beaker A took 48.4 seconds, but this one take 50.23 seconds, actually 28 means 3 seconds. All right, so what I'm going to do is for D, E, and F, I do first because all of this has to be done in room temperature. So later I will turn on this heater. So I am going to do now D for D. For D, I have to add, and then again I have to add 5 milliliter of HCl. Right. So for D, I'm adding 5 milliliter of HCl from here, and is the room temperature. Should be around the same. Okay. No change. 24 seconds gone. 25, 6, 7 seconds gone. No change. Nothing. Started. White. You can see it becomes whitish. I still can see. Gone. Okay, it is 49.3 seconds. So it is very much similar to the A and the B that I did. So it is 49.2 seconds. So it is B is 49.28. So should be 3. 49.3 seconds for D. Now I'm going to do for E and F. The same cross. E also at the room temperature, but it has different volume of water and different volume of sodium thiosulfate. So what is your guess? Will the reaction be faster or it will be slower? Can anyone tell me by the time I take HCl? So anybody, what is your guess that for E, do you think it will be faster, the reaction, or it will be slower?
Faster.
Okay, good. Who is it?
Lin.
Lin. All right, thank you, Lin. So it is faster. Does any of your friend support you?
Yes.
Who is it?
Chelsea.
Chelsea. Good. Thank you. So Lynn, you know your friends, yeah? Those who support you are good friends. Those who do not support, also good maybe sometimes that they want you to be correct. But for this case, other friends are not talking. So they are not supporting or what? Others, do you support Chelsea, Lynn or not? See,
Yes,
who is it?
Vanessa.
Vanessa, thank you. All right. So let me ask, who is there? Brian, are you there? No. Then Chamod, are you there? Ganesh? Dinesh, I think. Are you there? No, nobody is talking now. Okay, so for E, I'm going to add the 5 milliliter of HCl. 1, 2, 3. Nothing. Nothing so far. Yeah, the reaction started. I hope that you can see it is getting whitish, grayish, and then fast. Ah, cannot see anymore. It is 22.97 seconds it took for the mark to disappear. So I should put it 22.97. It's almost, 23 seconds. All right, let me be very precise. 22.99 actually. It asked me to put in 1 decimal, or anybody wants it, they can round it off to 23.0 as well. 23.0 second. Now I have left with this, the last one. Dinesh, Bilal, there? No. Now
Yeah.
nobody can. Oh, okay, so what is your guess for F? Will it be faster or slower?
It's faster.
Sorry,
It's faster
why?
because there is more sodium thiosulfate in the solution.
But there is same amount of HCl, right?
Yes.
So it's still faster.
Yeah.
Okay, good.
Because
So
the other solutions had more water.
yes. So one of the reactant is high concentration, and then from the stoichiometry, you can later discuss many things. In the discussion, you can come out with that. Okay, I'm going to add this 5 milliliter of, but anyone's guess how many seconds will it take? Given that the A, B, D, E, it took like 49 seconds, then 23 seconds, and then how many seconds will it take? Any guess?
13.
Less than 23.
Yes. Actually, I don't know who, I cannot see who said 13, but this is correct answer. I mean, it is much better answer because we do not know it's 13 or 10 or 3 seconds, but definitely it is less than 22.9 seconds it will take. Okay. So I'm going to add this 5 milliliter of HCl. 1, 2, 3. And it is started already. It's getting grayish, faster, fast, almost gone. Gone. Yeah, gone. Oh my God, who said 13? You won the lottery, man.
I did.
Oh, see, it's almost nearby to a 12.3 seconds.
Damn it.
Yeah, it's good guess actually, but it could be 10 seconds, it could be 15 seconds, but it is definitely less than 23 seconds. So it's 12.3 12.25, or let's say I just keep it 12.2 seconds. All right. Okay, so now I am left with C and B. That B I did not do it correctly because I did not look at the temperature. I have to do it at 40 degrees centigrade. So I'm going to do it over again, and I will be adding this sodium thiosulfate here as well. So bear with me, just wait a bit. All right, so again, 10 milliliter of sulfate I've taken, and then I have to add 35 milliliter of water to it. All right, so I'm adding 35 milliliter of water. And now I'm putting it on the hot plate. And I will measure the temperature using this thermometer. I hope that you can see. Right, I have taken the thermometer and I'm going to put it on the hot plate, which is I've turned on already. F, already done. This is B. B should be for 40 degrees centigrade, and which one? C is 60 degrees centigrade. So just let me show you how I'm heating it up. I'm moving slowly so that you don't feel dizzy. Here, I put it on the hot plate, and this hot plate is on already. Can you see? Yeah. So this hot plate is on, and it will take some time. Still not hot. It will take some time, maybe a few minutes, 2-3 minutes, hopefully. More than that. So do you have any questions so far? Any inquiries or are you curious about anything? Oh, by the time you see the sulfur is precipitated because solid sulfur is yellowish color. So is it yellow color or something like that? Yeah, so you see all of them become this yellowish because of the precipitation of sulfur in these beakers. All right. check. It should be 40 degrees centigrade. The room temperature, oh, I have to tell you, right? The room temperature is 25, 26, 26, 26 degrees centigrade. Now I'm looking at the temperature for solution B, which is yet 28, not 40 yet. And it will go up fast, very fast, actually. We should have some digital thermometer, so it is easier, or IR thermometer maybe. $28 yet, so it will take some time. It will be like that. And if it is too hot, then I'm just leaving it there. Yeah, it's difficult for me to use one hand. Water temperature takes some time to increase because water has a good heat capacity. So it can hold the temperature for some time. It's not easy. It takes much energy. Yeah. So can you tell me that the water that I'm heating up, is it an exothermic process or endothermic process? Anybody?
Endothermic.
Yes. Thank you. Because I am providing heat to the system, or to the system, and the water is taking the heat and becoming hot, is gaining the heat from outside, or from here is the from hot plate, but normally it's from taking from other source and getting hot. So that is why it is an endothermic process. If water would emit heat, that would be exothermic. It's 35 degrees now, another 5 degrees. I have to wait for maybe another few seconds. It will go there, hopefully. $36 no, 35.5, back, going there, going there. So everybody of us know that there will be exam or mid-semester test on 23rd of October, right? Does anybody not know here? All right, it is 40 degrees now. Okay, so I'm going to bring some AC now. So the thing is, does anyone, I mean, what do you think? Will it be faster? Will it be slower? Will it take longer time or shorter time?
Reaction will be faster.
Okay, good. Because of the higher temperature, yeah? The temperature dropped to 238 degrees. So I'll keep it up for maybe 10 seconds. If by providing heat, the temperature is faster, so what type of reaction is this? Exothermic or endothermic? Okay, it's 40 already. Now I'm going to add 5 milliliter of ACl and then count. Nothing. 8 seconds, 9 seconds, 10 seconds. Started. Oh my, going. Still can see. Vanish. It's 21.8 seconds. So for C, it should be 21.8 seconds. No, sorry, for B, 21.8 seconds. For C, it is 60 degrees centigrade. So let me see whether 60 degrees, yeah. No, it's hovering around 45 degrees centigrade. So it will take some bit, it will take a bit time to reach there. Right. So here, and we are almost done. Just wait for this. So afterwards, what you will do is you will graph this graph against temperature. So put the temperature maybe y-axis and then the reaction time in x-axis. You know what is y, what is x, right? I'm guessing that you know already. And the rate of reaction is just 1 over time. That means 1 over 21.8 degrees, 21.8 seconds. So that is the rate of reaction. Rate of reaction means how fast the reaction is going per minute or per unit of time. For us, the unit of time is second here. The per unit of time, how fast it's going. And then we will do the graph to see the temperature and the rate of the reaction relation. And how do we find the relation? If we do it by hand, it is difficult, but if we can do it on Microsoft Excel, the Microsoft Excel will give you the R squared value, right? The graph R squared. So how good it is fitting the line of the regression line, or all those things it will give. So you can try that way as well. It is 53 degrees now. So maybe it will take another 1 minute to reach to 60. Okay, 55 almost. So 5 more degrees to increase the temperature. And then we will be done. So once again, for an announcement, those who are coming to the lab for next week after the semester break from experiment 6, 7, and 8, please send me your name, all right, by tomorrow. If I do not get your name, then I cannot tell my lab assistant to prepare for you. Okay, so please send me your name, those who are coming to lab. It will be fun. Only you have to be careful on the SOP and all those things. $58 going up, 59, almost 60. Right, almost. Just let me take. Okay, so it is 60 degrees now, and I turn off the heater. I put it on the mark, and I take the stopwatch, and I add HCl. 1, 2, 3. So yeah, reaction started, and gone. It's just 9.2 seconds. It is gone at 60 degrees centigrade. Okay, so for C, it is 9.2 seconds. All right. So this is, the data will be given to you later on. A different data you will get. So you just have to prepare your report accordingly. But from when you are coming to the lab, right? The data you will be using your own from that time. Okay, so this is it. Anybody has any question so far? And you can see that all becomes similar. The color of the sulfur becomes similar. Okay. So anybody has any question? Doctor?
No.
Okay, thank you. So I will see you tomorrow then.